Okay, hi again. So this is like a redo of a talk that I did at Toronto's OWASP meetup in December, OWASP being the Open Web Application Security Project. I did a talk there on their IoT top 10 list. OWASP publishes these top 10 lists of like web app vulnerabilities, and I think it was 2018 or 2017 was their first IoT top 10. Well, because they realized that the vulnerabilities in connected devices in our homes are slightly different than the vulnerabilities that we see in popular web apps. And I think they wanted to address that with a list of common things. So I put together this talk, which is supposed to be an introduction to that list, and then trying to figure out where do these problems come from. And you'll see the disaster that was my attempt. So normally for the OWASP audience, they wouldn't know who I was, but you do. But whatever, I'm going to introduce myself again. Hi, I'm Nick. I run the security degree. Hi, Wes. I run the security degree at Sheridan College. And before that, I did forensics and incident response, and I was a pen tester, and I was a developer. And I used to be a cook a long, long time ago, but whatever. I do stuff on Twitter. I also like to make things, like electronics and stuff like that, and I like to learn about electronics. That's why the security and the electronics bit mushed together, and I decided I should do a talk. So what is the talk going to be about? Well, why did I want to do this? Then an intro to the top 10. Then my thing that started out as a case study that turned into oh my god, I have to get this thing to work, and that finally just became, this was an experiment in making an IoT product. Things that I learned, some suggestions around security, and then in theory Q&A. Stuff that I don't want to mention, weird stuff that involves nation states, like people injecting weird chips into your manufacturing chain on the assembly line. That questionable Bloomberg article from last year talked about. Other stuff, I wanted to focus on consumer products, not stuff we see in industrial control systems and in utilities or the medical industry or the military. They have their own IoT problems. I just wanted to look at the smart fridge you have in your house, stuff like that. I also don't want to talk about the impact of the problems with these things, because we know what can go wrong if I have a rogue Wi-Fi toaster. I just wanted to understand, why is the Wi-Fi toaster such a crap product to start with? We have lots of things that have Wi-Fi in them now, right? Everything from doorbells and plugs and whatever the hell. This is to thermostats, to yes, toasters, or your smart home assistants, or locks, or honestly, I have no idea. I found this picture. I didn't even read the product posting. I was just there's eggs in an egg thing, and someone's obviously doing a Wi-Fi with it and putting this picture in the presentation. Does it let me know how many eggs are left? I do not know. Evidently, though, eggs have Wi-Fi. So anyways, I just Googled smart home, or searched for smart home on Amazon, and that's how many hits I got. So there's a lot of stuff, right, that we sell that has Wi-Fi in it. And we do it because we like convenience, right? I want to be able to turn my lights on with my smartphone, but there's a cost to that convenience. We have things like code execution, meaning, again, someone can run random programs in a smart plug that I have in my wall, or we have devices getting taken over and made part of botnets, or we have researchers showing that, seriously, they could man in the middle a Samsung smart fridge to then start doing stuff with it again, put it on a botnet, or spy on users, or just know the contents of my fridge. I don't know. But there's basically, we have these things, they are vulnerable. That means that these conveniences actually become threats to our, home in a way. So why did I want to talk about this as a problem? Honestly, there was a lot of talks at Black Hat the last 3 or 4 years about it. There's also been talks at all the other security conferences. I just listed the Black Hat ones because they have this cool little search feature on their website that gives you those numbers. I didn't want to have to go read through all the DEF CON things to find out which talks were about IoT. Also, OWASP released their IoT top 10 list in 2018, and I happen to like electronics and security, so it was this would be a cool thing to think about and talk about. But mostly, last year at Sector, which is the Toronto big Toronto-based security conference, Lee Brotherston, who works for Ecobee, sorry, Lee, I usually say that wrong. He did a great talk on IoT security and an insider's perspective. And basically, Lee used to work in the general consulting InfoSec world, but then went to go work in-house at a IoT vendor, and talked a lot about some of the challenges that security faces on the inside of an organization. And it was really interesting because a lot of the stuff that we in information security usually say, oh, this is so easy to fix. He came up on stage and he explained, yeah, I used to say that too, but then I started working for one of these companies, and now I know why it's not so easy to fix. He described a couple of things that I'm going to touch on in the presentation, so I'm going to explain them real quick. First off, he said one of the problems is that you have things in places, meaning your ability to do asset inventory on all of your Wi-Fi devices is very difficult, right? Maybe I sell my product as the manufacturer, but maybe I also sold like 1 million of my product to Canadian Tire and another 1 million of my product to Walmart and another 1 million of my product to Amazon. I don't know at any point in time which of those products are sold and which ones are not, which ones are plugged in at people's homes and which ones are sitting on shelves in warehouses. So from trying to understand how much of my user base got their most recent patch, how many of them are running outdated versions of the software, how many of them are actually connecting back home, you can't know that stuff. And that's a big challenge compared to in an organization where I know I have like 200 employees who each have a laptop. I at least know how many devices should be connected and should be updated within a reasonable amount of time. This is a much harder problem. Also the idea of identity and access management, right? With my own users, it's great. I can manage their credentials, I can enforce policy on them, I can do all that kind of stuff because they're my own users. But when I give you, or when you buy a product from me or from just one of my suppliers and you take it home and you plug it in, I have no authority over your network. I have no ability to enforce policy on you. I don't even know who you are. You might be a trustworthy entity. You might be an untrustworthy entity. I do not know these things, and that's a challenge. They also want low friction deployment. So I come home with my like smart fridge. I want it to work. I want it to do the smart things, and I don't want to spend like hours going through configuration menus, setting up like 2-factor authentication for my fridge, for getting my fridge on like, you know, setting in, doing security config for my fridge, right? Marketing says no. I want people to go home, they plug it in, maybe they enter your Wi-Fi password, and that's it, right? Software supply chain. So we run embedded software on IoT stuff, and I mean, that basically means every IoT manufacturer becomes an operating system developer because they all have to maintain these tiny code bases that run on hardware, and that's challenging. A lot of hardware protections are not feasible for consumer grade IoT. So yeah, we can make it so that when you take the cover off something, like the chips inside like melt or blow up, or like they basically can't be used once someone tries to get into it. That stuff's really expensive. And that stuff can maybe be put into like $30,000 firewalls, but not into like a $5 plug that goes into my home. So I have to assume that basically someone will get physical access to the device and compromise it. There's also revenue challenges. He spent a big part of his talk talking about how like security's budget is structured in that they get so many pennies per product sold. Right? Because you also have to pay marketing, you have to pay advertising, you have to pay manufacturing, you have to pay research and development, and all that gets factored into how much money do we make off of one product. So everybody gets a few cents off of that. So try planning a security team, a security like budget off of that kind of a pricing model. It's very difficult. So that's sort of the background. The OWASP IoT top 10 list. So the most common vulnerabilities with IoT products are weak, guessable, or hard-coded passwords. This is such a common problem that there are entire websites devoted to like searching for default usernames and passwords for IoT products. Cool. So I just put in a IoT device, like Wago or maybe Belkin or whatever, and it would just show me, hey, if you want to like remotely connect to this thing, here's probably the default creds for it. Awesome. That's a really useful thing. So what do they mean by that? Easily brute forced, publicly available, unchangeable credentials. That is a big problem. How do you change credentials in something you can't even log into as an end user? So this is some of the challenges that they face for weak, guessable, or hard-coded passwords. Number 2, insecure network services. There are so many stories of lame IoT products that basically have Telnet or SSH or FTP just running on it for no reason. Like, why do I need to Telnet into my lights at home? I don't. There's no reason I would ever need to do that. I have a perfectly good app on my phone that I can use to change the color of the lights in my home. Why do they leave a Telnet server open and running on it? Probably because, well, reasons we'll talk about later, but basically lots of insecure services that leak data or could be used to compromise the device, take it over and use it as a botnet, stuff like that. We don't need those things. Number 3, insecure ecosystem interfaces. So if you have a smart device and it connects and talks to stuff in the cloud, or you can modify the device through a web browser, that basically means that you just have standard web application vulnerabilities. So this was like OWASP's nice way of tying into their regular top 10 list. So it's all the problems we typically see with web apps, like missing authentication or bad authentication. I don't know, weak encryption or no encryption at all, like bad data validation, all the standard stuff that goes wrong with software. You have all those problems in the IoT world as well, because your IoT devices talk to the cloud. Lack of secure update. Oh my goodness, so many challenges with updates on IoT devices. First off, you need to make it like updates easy and automated for IoT stuff, right? Because honestly, like who goes and intentionally updates their smart toaster or their smart television? Nobody. I think somebody pointed out, there was like a video on YouTube of one of the smart TVs, and there was they walked through the process for how to update the smart TV, and it was like 17 clicks through different menus and stuff, and nobody's gonna be doing that, right? There's also problems about, like if I push out an update on an IoT product, it better work. Because if I push out an update and it bricks your device, you're never buying one of my products again. Because my software update broke your toaster and now your toaster doesn't work, or your thermostat, right? So like you kind of have like a one shot to get these updates right. So you can't do continuous updating that a lot of software companies do. A lot of them don't have rollback or anti-rollback mechanisms because you don't want people to be able to force old insecure code onto a device. The updates weren't encrypted in transit, so you can like man in the middle of the update and put backdoors in the code and stuff like that. So lots of problems and challenges around secure updates with embedded hardware and devices. There's a really cool article from some researchers at Carnegie Mellon University. They were looking at diagnostic tools for automobiles, and they found that the diagnostic tools, when they got updates, the updates were not cryptographically signed, they weren't encrypted as they were sent over the air, and they could basically make all kinds of malicious modifications to the diagnostic devices that would then compromise the car itself. So they have a paper up that you can read about that, it's interesting. Use of insecure or outdated components, basically, this just means bundling old insecure software in with my IoT software. So maybe I use an operating system, like an embedded operating system that's not secure. Maybe I designed all my products around a certain CPU or a certain microcontroller, and we find out later on that that chip is vulnerable to something. Well, tough luck. It's already in 3 million of my product. It's already out there. There's literally nothing I can do about that. So these problems like Spectre and Meltdown and Heartbleed maybe probably exist in a load of IoT products, and there's nothing we can do about it because you can't update that kind of stuff in that kind of situation. Privacy. Most IoT products are like, what's privacy? They basically don't encrypt data. They transmit data over unencrypted channels, things like that. The whole ecosystem lacks a lot of safeguards around privacy. And we might sometimes just say, hey, yo, throw encryption on it. You're fine. Once the data is encrypted, there's nothing that can happen. But unfortunately, even when you do the right thing, which is do the encryption, researchers at Cornell found that with a bunch of smart home devices, which were like thermostats and stuff like that, just metadata that they got from watching traffic was enough to leak data about the owner of that device. They could infer a lot of information about the people that had that device in their home just by looking at the metadata of the encrypted traffic. So that's a challenge. Insecure data transfer and storage. Yeah, there's just no encryption in these things. Apparently it's difficult to do crypto. One of the challenges, because in software it's kind of easy, but sometimes hardware makes it difficult to do crypto. So this chip that you see in the top right corner there, yeah, right, cool. The ESP8266, which was a really, really popular microcontroller for a few years because it basically has a full TCP/IP like 802.11 Wi-Fi stack built into this tiny little chip that you could get for like $2 a pop, or these days like $1 a pop on eBay and AliExpress and all the usual suspects. So a lot of people were making IoT products with this because, oh my god, it was a Wi-Fi chip for $1. And you could kind of custom build firmware for it, and there's sites like Node MCU builds, which would allow you to customize and build firmware for these things. And they ran some stats, and they found out that, I forget what year this was, 2017. In 60 days, they found about 13,000 plus custom firmware builds for the ESP8266 chip, and only 20% had SSL support, and 10% included the crypto module. So like, that's a lot of firmware and builds for these things that weren't doing encryption. That means lots of plain text web traffic. So I bet some fraction of those were prototype devices for products that went into production. Some chips just don't have hardware support for crypto, so you have to do it in software. And you use up a lot of the space on that chip if you dedicate some time for doing crypto in software. It's a challenge. I'm not saying they were wrong for doing that. It's a constraint that you have to deal with. Lack of device management. So there's no, that problem I mentioned where you have things in places and you don't know where they are. That's basically this problem. You don't really have a good idea of how many of your devices are connected, what their update status is, if they're working properly, because they're all over the place and they could be everywhere. The problem here is, though, is even when we know all that stuff, like if you take a regular computing environment, we as security professionals are really, really bad at standard asset inventory. So many organizations couldn't tell you the patch level and update level of their laptops. Turns out lots of people still track this kind of stuff in Excel. Lots only verify like device location and if they exist like, once a year, or some of them every 5 years. People spend a lot of time trying to get the asset inventory problem solved, and that's in regular IT environments where you know your employees, you know your assets. Never mind an IoT environment where you don't have control over any of this stuff. In secure default settings, yeah, these things ship with settings that no production system should ever have. For example, an FTP directory that's read, write, and execute by literally everybody. Web servers running as root, so if I compromise their web server, I've rooted the device. Like all this kind of amazing stuff. Basically, that's it. Probably like artifacts from development that were left over. And last, lack of physical hardening. Yeah, because securing things against physical attack is really costly, really expensive, and typically not within the budget for a standard consumer IoT product manufacturer. Maybe they put the sticker on it, and we all know how good that sticker is. They used to get away with it by doing things like not labeling debug and serial ports on PCBs and on boards and stuff like that. But now we have tools like the JTagulator and all kinds of other stuff that can allow us to identify all of these ports really, really easily. So we can't rely on security by obscurity for IoT devices, and hardware just does not work. So the experiment, I wanted to find out why do these 10 things keep happening in IoT devices all the time, because it's quite common that we see those problems. So I wanted to try to put myself in the situation of maybe some of these developers and product manufacturers. A couple of constraints, like I wanted to understand the pressures of getting to market really quickly and the compromises you make when you're trying to do that. I also wanted to pretend that I was unfamiliar with the IoT product development process. No problem there because I wasn't. I've never made an IoT product before, so that was not going to be a problem. And lastly, I had to pretend that I was unfamiliar with secure software dev practices. So I got drunk. I don't know. I had to forget stuff, so that's what you do. I boiled it down to, fine, I'm going to try to make something in 24 hours to kind of simulate the rush of getting to market. So this was my scenario. My scenario being, it's after exams and you go to the pub to celebrate being done exams. And when I was a student, we would go and we would get website drunk. Getting website drunk basically meant sitting around with your friends going, man, I hate school. I just want to come up with like $1 million website idea so I can stop doing this, right? And we would get drunk and talk about all kinds of ideas for that. I assume now people just go get IoT product drunk. They're like, hey, what can we stick Wi-Fi in that'll make us $1 million so we don't have to go to school anymore? So I was sitting there thinking about this and I was like, oh, smart mirrors. Whenever I see a smart mirror project on like Hackaday or the internet or whatever, I friggin' love them. These are those mirrors where like they just have data so you can see yourself, but I also know what the weather's going to be that day or when like my next few trains are going to be and stuff, because I am not a together human being and I don't think to look at that kind of stuff before I leave my home, right? So if I saw that in the mirror, like while I was combing my beard, amazing. I would know if it was going to rain that day, so I would know to grab an umbrella. I probably still wouldn't, but whatever, I can pretend that I would. So ultimately, all a smart mirror is a piece of like one-way or, what do we call those? One-way or two-way glass, whatever, with like a monitor strapped to the back of it. That's ultimately what these things are, because if the light source is close enough to the back of a one-way mirror, it will shine through, you will see it. So that's what a lot of these projects are. I found out later you can even just buy like a film that's reflective on one side and not on another. So you can get a piece of like acrylic or plexiglass or whatever and make that into a one-way mirror. That's neat, I didn't know that before. And a lot of them just have a simple computer strapped to it that's then making queries to some API on some website to gather that data. Really though, that's what a smart mirror is. So here I was in the middle of my situation. I'm like, okay, so other people are making smart mirrors, so I have to be first to market because I need sweet, sweet venture capital money so I can stop going to school. Turns out I had a friend that works in television and they managed to get me a spot on one of those venture capital pitch shows, right? Unfortunately, Dragon's Den and Shark Tank don't do IoT stuff anymore, so I was going to be on Goose Roost, which is going to be amazing. This is a thing where they just like ding you off with a bell or they honk at you if your product sucks, right? So it was the start of the day and I started thinking, what am I going to make? Well, I knew I was going to make a smart mirror. Obviously, I have to do the important stuff first, right? Like I have to come up with a cool product name. And after a bunch of dumb ideas, I came up with Brain Mirror. Not that that's any like less dumb, but that's what I thought. Then I have to like pay $10 to register a domain name, or if you're cheap like me, you just load your domain name into your etc. hosts file, and all your code will work, so that's fine. And then obviously you need to bake memes into your logo because you want to capture that youth market, so you're good, like you're ready to go, right? But before you do all that, then I was like, oh no, crap, I need requirements for this product. Like, what does it actually have to do? Because I have to put constraints on myself, right? We're trying to simulate a real world thing here. So at that point, it was probably like noon, because I took a long time trying to Photoshop the brain thing into the mirror. So like, I was like, okay, well, obviously it's gotta be cheap. Nobody's gonna shell out a lot of money for a smart mirror. I don't want people to have to pay subscription fees, because nobody's gonna pay me a $5 a month subscription for their mirror. I wanted to try this low friction deployment thing, so it should be pretty easy to set up and configure as a regular user. I want it to be easy to use. And hopefully it should work. Like, I'm not great at code, so maybe not. So I went through my bin of dev boards to see what I had. Raspberry Pi Zero with Wi-Fi, cool, that'll probably be good. But ultimately, anything that'll do Wi-Fi and can run embedded Linux would work for a project like this. But I had one of these and they're like $10, so that's fine. Here's my prototype, where I just took whiteboard marker and drew on my mirror, and this is kind of ultimately what I wanted to build. There's the Pi, and here's all my data readout with emojis, because why not, right? That, by the way, is going to be featured on Netflix's Nailed It IoT edition, because that's like, honestly, best smart mirror you've ever seen. Right? Anyways, so the general solution for the project, I kind of sat around and thought, okay, so the Pi itself, because I got to get a user to connect to this thing and set Wi-Fi credentials. So the Pi was going to start up in access point mode. So it's just going to be like its own little Wi-Fi network that you could join, and it would ask you for stuff. Right? So the user would connect to that maybe with their phone or a laptop or whatever, and enter the Wi-Fi details for their home. Right? Because otherwise, how would this thing know what your own Wi-Fi creds are? Then it should bounce you to like a login page where you can do this setup for your mirror, because you'd have to tell it, hey, what train schedule do I want to see? What city do I live in, so I can get the weather for it and stuff. So I'd have to figure out a way of getting your user to like a registration thing. But then I want to save all that data up in the cloud, because everything gets saved in the cloud. So I have to figure out how to do that. Then the device would basically reboot. The monitor should be in full screen mode with no buttons. It should go right to the web browser, right? Like, I want to make this thing look really slick and smooth and stuff. I don't want to see no buttons, no nothing. And then basically at that point, the device is just on. It should be regularly pulling the internet for data that it's going to render in this display. Okay, so I had some challenges here because some of this stuff I had no idea how to do. Also, because at this point, I think I had like 8 hours left. So I abandoned some stuff that would have made this really good, but really time consuming to set up. And I just went with what I already kind of had running for some other projects. So there was no Amazon, there was no Docker, there was no like React for fancy looking front ends. There was like, I had some credit on DigitalOcean for my cloud servers. Obviously it was running on a Raspberry Pi, so I had to use Raspbian as the operating system. I know Python, and I know the Python web framework called Flask, cool. For data storage, I was gonna try using Redis because I did not have time to make proper database tables, so screw it. I'll just throw everything into a Redis data store as JSON. If you don't know what those words are, that's fine. One day you'll know, and then you'll not like me for knowing those. The Raspberry Pi setup, first off. So I grabbed the latest operating system, which is Raspbian, so I downloaded that. And then what I had to do was make a copy of it onto an SD card, so I DD'd it over. That's fine, I'll give you these if you want to look at the commands. Then I booted the Raspberry Pi, I went through the standard Raspberry Pi install, added some extra Python packages and stuff like that. And then I shut down the card, or shut down the Raspberry Pi, and I made a copy of it. Because the goal here is I want to be able to make this thing ready for mass production. So I want to have an operating system that I can just flash onto millions of SD cards and plug into devices and make lots of money. So I wanted to have all the software preloaded. So I went through all the install for the Pi, and then I mounted the little image for this thing, and at that point I could copy all my code onto it, and then I could unmount it, and it would be ready to go. Okay. Now I could just kind of DD this thing onto lots of SD cards. Other stuff, I wanted this thing to basically boot with no password to the desktop and full screen the Chrome web browser with no buttons or nothing on it, right? I didn't know how to do that. So turns out you can make some configuration changes like this to the Raspberry Pi that will basically make it boot with no login prompt, no nothing, which was cool. So now you know how to do that. Then I wanted it, so this is the point where when someone first buys my mirror, right, and they plug it in, I need this thing to start up as its own Wi-Fi access point. And again, I had no idea how to do that. So apparently any code you put in, etc., rc.local will run every time the device turns on. Okay, because sometimes power will go out and we need to account for all this stuff. So I'm gonna run a program. Basically, if it already has a text file called Wi-Fi creds, then I'm basically just going to go and run the regular mirror that you should see with all the cool data on it. So something that I learned, if you want to get basically like a screen of any kind to basically load with a web browser loaded with no buttons to have it go full screen, this is the command you can run. So Chromium or Chrome if you have Chrome. And then you can point it to the website that you want, and then you say start full screen and in -- kiosk mode, meaning there's not going to be no buttons, no nothing. That's the command to basically just full screen a GUI app when you boot it into Pi or something, or any operating system. That's cool, now I know how to do that. If there were no Wi-Fi creds, meaning this is the first time we're being plugged in, then I had to start a different app. So Mirror in one case, or in the other case, the Setup app. In Setup, it basically just threw this message up on the mirror, and it said, yo, you just plugged in this Wi-Fi mirror for the first time. Please go to this IP address. And I could hard code that. So the person could take out their phone or their laptop, go to that address, and go to /wireless. Or you had to connect to the network that it was broadcasting, and then you could go to /wireless. When you did that, there was a setup page and said, hey, what's your wireless network? What's your password? And you hit submit on that. Right, and then it would send that down into the Raspberry Pi, which could then connect to your Wi-Fi network, and you were good to go. Here's how we would reply to that. So you send me a request to Wi-Fi. Don't worry about trying to read the code. It's fine. I would grab the SSID and the password, which we sent as part of this form right here, and I would spit back a message saying, "Hey, good job." And then it occurred to me that like if your phone was talking to this thing, I just turned off the access point and connected to your Wi-Fi. So then how does your phone know where to go? I was trying to figure that out, like how do I send a message to the phone before I disconnect and stuff like that, but I wouldn't know the new IP address. Like it was all kinds of problems. So I realized, oh wait, I still have a mirror. So I threw up this message on the mirror that said, hey, now I'm on your Wi-Fi network, so please just go to, and I would figure out the new IP of the machine and tell you to go to /config, and this would help you set up your mirror. So here's the config page. Basically, what's your username? What's your train station, and where are you going to go? And I don't know, themes, if I knew how to make themes. So you would fill out this form and you would submit it, and then bam, your mirror would be all configured and it should just start doing stuff. Here's the form. It would send this register form to the mirror's internal web server. And then here was the I had this thing called hidden, which was some kind of key that had a big long number. This was my attempt at security, basically by embedding some secret key into the form with no encryption. That's fine, whatever. I'm not going to go through this, but if you ever want to actually configure a Raspberry Pi or another device like that as a standalone Wi-Fi access point, here's the code that you do, or the commands you run to do that. So you just tell it to be an access point and to run DNS and stuff like that, the IP range you want. Then you can tell it, you know, what do you want the Wi-Fi network name to be, and all that kind of stuff. And then basically that will turn these devices into a standalone Wi-Fi network, which is kind of handy in some situations. Anyways, so imagine now the mirror is on your Wi-Fi, it's configured. Now we still need to like have data in the cloud somewhere. I want to store your user profile for the mirror so that if you, I don't know, move somewhere new and you set up the mirror again, it should download your profile data for you. So this is what you would run on your cloud provider. Basically SSH'd into a virtual machine that I had up in the cloud. I installed some stuff. I cloned my code repo. I installed the requirements, and then I just turned my mirror service into like a service that runs forever. That's basically all that did. What does the server actually do? This is all boilerplate code for getting a Python Flask app up and running, and there's also a shared secret key that keeps other people from using my service, which we saw in a form earlier. The device registration, all it does is it just takes all the data you sent me when you registered your device and it throws it into basically a Redis database. Don't worry if you don't know what that is. Basically, I just lump all that text, like your Go train station stop and whatever, and I just dump that into a storage mechanism up in the cloud somewhere. Here's the code that the mirror uses to retrieve data. Basically, every, what's that, like hour? It asks the internet, yo, here's the secret key and here's my username. Give me all that person's data, and then it draws it on the mirror. That's it. It just uses the same key as every other user and sends it a random username, and it will draw all the data on the mirror for me. I'm not actually going to show the draw data function because I didn't write it, because this was like 11:30 at this point. On the mirror, so like on the server side, I'm basically receiving your request to get mirror data. I'm checking to see that you have the same key as everybody else. And whatever username you sent me, I'm going to grab all their data and shoot it back to you. That's how it works. I realized I also had to add a software update feature because software updates are cool. So basically, once a week, the mirror will ping the cloud instance and it'll say, hey, here's what version of the code I have. And the cloud will say, okay, well, I have a newer version than that, so here's the new version. But basically the way it does that is it turns all the code into like plain text and just spits it back down the internet at you, and you receive that and you just write it into a file, and that's your software update. It works surprisingly well. It's insecure, like it's like Swiss cheese. It's so full of vulnerabilities, but whatever, it worked. And I wrote it in like 20 minutes, so I was really happy. At that point, I was like, okay, I've made the most insecure mirror ever because there was no actual encryption. Everybody had the same key. There were so many problems, but it was like the end of the day, and I had the basic functionality working, so I was like, good, fine, this is good enough to make my point. So kind of like what went wrong with this? First off, weak guessable or hard-coded passwords. Yeah, I had one of those. I had this like shared key that everybody knew. The idea was it just basically kept people that didn't have a mirror from talking to my service, but it wasn't very hard to figure out what this key was. This is one of the problems in IoT where we have untrusted connections the first time someone connects a new IoT device. Like, how do I know who you are? How do I know that you should be able to talk to my system? There apparently are protocols for doing this properly. I just didn't know them. And I thought, oh, maybe that's one of the problems that these developers have. Maybe they just don't know the right way of doing these first few steps to make sure that trusted entities are connecting right the first time. Insecure network services. Yeah, in my rush to do this, I forgot to turn off SSH to the little box so anybody could SSH into my mirror. I actually never turned off that like local web server that you use to initially like register and connect to the device. Just forgot to turn it off, so that was always running. Why? Turns out, yeah, sometimes developers forget things and they just leave them in there. Things that were used to make development easy, they forget about it in the rush to finish the project, so it gets left in there. Other things that went wrong, insecure ecosystem interfaces. Yeah, everything on the server side up in the cloud was insecure as heck. There was no real authentication or authorization. Everything was plain text. There was no encryption. I didn't do any data filtering at all. The output had all kinds of potential cross-site scripting vulnerabilities. It was C-surfable. Again, maybe people just didn't have the time. Maybe they had outdated notions of that. Of what, crypto overhead in hardware, although it's not really a problem anymore. So maybe that's the origin of those kinds of problems. Lack of secure update mechanism. Honestly, I'm just happy it worked at all. But yeah, maybe I just didn't know the easy way to solve that problem or the correct way to solve that problem. So it was kind of whatever the developer thought of for an update mechanism, and that's why there was no crypto. Privacy protection and data in transit and storage. So there was no encryption. I just didn't have time. There was other stuff I thought about too, like I could start pulling other people's configurations because it would accept whatever username I gave it. There's potential privacy implications in that. Didn't even think about that. I didn't build in any way for someone to delete their configuration information that was up on the cloud. That's in violation of a bunch of the new privacy legislation as well, so whatever. It's just, that's all I could figure out how to do. So the question is, would it be easy to fix these? Yeah, but the problem with making stuff that works is that the second it works, someone's going to push you to, okay, good, now we have to go to market, we have to sell it. You don't have time to go back and fix it and do it the right way. So I think one of the lessons here is always do it right the first time, because there is nothing more permanent than a temporary fix. So I looked at what did all these problems I did have in common? Well, obviously the rapid pace of development was a problem. The product requirements around the low friction deployment, making it easy to use. And also just some of the protocols and security stuff I just didn't know off the top of my head, and that was a challenge. So I'm sure other people face those challenges as well. So those are some of my thoughts on what the actual root causes could be. What can we do about that as security people? Can we make ecosystems like server side and cloud side and operating system that are secure by default, so that IoT developers just have to install this OS and it's ready to go? It does all the secure stuff by default? Yeah, sure. People should do that. It's probably a hard project, but whatever. So yeah, a secure base OS, or even using container services like Docker might be cool. Can we start building libraries and frameworks that make some of these challenges really easy to solve. Like this problem of me connecting the first time, or around managing user identities and stuff. Can we basically make that a function call? And then we've made it really easy for the developer. And finally, education and training. Obviously, people need more of that, so the IoT top 10 list is probably a good place to start. Anyways, that was it. Thank you. I had an hour to do that last time, and Luai told me I had 20 minutes this time. So, yeah. Anyways, let's take a break for like 5 minutes while our guest speaker gets set up, and then you come back and listen to a far more interesting talk. It's part of the